So hello everyone. I think remember in the last session we end with the part 2 manual load calculation. So in this session let me start part 3, which is a software load calculation. I'm talking about the HVAC software load calculation, and as per the syllabus we are offering HAP hourly analysis program. So you already know this module 1, which is a HVAC design. I divide into 5 part. Part 1 is a HVAC design basics, which you already completed, and part 2 manual load calculation, which also we did. Now we are at part 3. So part 3 is a software load calculation, and as per the syllabus I'm offering HAP hourly analysis program from Carrier. And part 4, HVAC air system, and part 5 will deal with the chill water system. Okay, so we are at part 3 now, HVAC software load calculation, in which we'll deal with the Carrier HAP with the sample project and as well as the school project. Sample project I'm going to continue the same what we did in the manual load calculation, and school project will deal with the 12 spaces with VAV package system and CAV chill water system, and also will deal with the VRF. So let me proceed. I'm going to share the screen. So on screen you can find out, you see part 3 software load calculation, Carrier HAP, and what are the topics we are going to deal in this part 3 Carrier HAP. Let me show on screen. So you'll get two projects. One is a sample project and another is a school project. Sample project with the single space, in that we'll deal with the split system, and school project with 12 spaces, and with the school project we'll deal with the package VRF system and chill water CEV system, and also we'll deal with the VRF system for the same school project. So here you can find out part 3 software load calculation analysis program, and we are dealing with the 5.1 version. So here you can find out sample project and the school project, and optional project for the practice, that is a villa project. And I think remember in part 2 we extract the data of the villa project, and that villa project also we can consider as a additional project to use in HAP for your practice. Okay, so in the class we'll deal with the sample project and the school project, and villa project will be additional for you, and what we learn at the time of part 2 at the time of data extraction. So after extracting the data you can use as additional project for practice in HAP. So here you can find out, I'm considering this as chapter 7.1 in this part 3. So chapter 7.1 is a software load calculation. So we'll start with the what on screen, then we'll deal with the basic settings which is required for the project. Then we'll deal with the weather, and after that with weather we'll deal with the library, how to create the library. Then we'll think to deal with the spaces, and after completing the spaces we'll create the system, and in the system we'll link the space to generate the report. This is just a quick summary. So chapter 7.1, in that you'll find this software load calculation tab with the two projects, and chapter 8 will deal with the machine selection. Okay, so these two chapters I'm considering in part 3. So let me proceed. So here we are dealing with the part 3 software calculation Carrier HAP, and if you not practice this manual calculation, I request to please do that practice, so that you will not get the confusion in this software calculation, and you can focus on the software, how to use the software. Okay, because in software we are going to provide the input, and the software will provide you the output, the result based on the user input, and the user input is based on the concept, and the concept we did in part 2, the manual calculation. So already I explained in part 2 about the importance of this part 2, because this part 2 was the foundation or the base, nothing but the manual calculation, and that same concept will use in the software now in part 3 software calculation. And as per the syllabus I'm offering HAP, Carrier HAP, that is hourly analysis program. This is originally from Carrier, the software, and popularly used in market for the load calculation. Apart from this, you'll find Elite CHVAC or RHVAC software, or you may find Havacom, or you may find this LG load calculation software or Zamil load calculation software. So you'll find n number of software for the load calculation, but commonly used or popular in market is a Carrier HAP. Okay, and if you know this HAP software, you can try other softwares also, because you see, in any software the concept is important, and concept we already discussed in the manual. And if you know this HAP software, and HAP is offering n number of options, so that you can able to deal with any other software, like you can try Elite software, or any other load calculation software. So just here in this part 3 will deal with the HAP. And first with the sample project. After sample project, we'll deal with the school project. Sample project means I'm talking about the same sample project what we did in the manual for comparison point of view, and we already have the input of the sample project now, so that you'll get the overview of the software, how to give the input for weather, for library, for space, for system, etc. You'll get the overview for entire options in HAP with a simple one room sample project, and so that we can easily deal with the 12 spaces in school project. And one more reason why I'm providing this sample project in HAP first before school project, because in school project we'll use the ready-made input file. In that you'll find the location, that is Chicago IAP International Airport. So if the locations are available directly, one can select and the software will extract the weather data. But in case if the city is not available in the software, how to provide the input, that we are going to learn in sample project. Likewise, you'll find some options which you cannot find in the school project. That is also one reason I'm providing this sample project in HAP. And apart from this, for to compare the result with the manual. Okay, in manual we got around 2.8 TR, na? So we'll compare the result also with the software, and we'll find slight difference, and why the difference, which is more accurate. That also that is the discussion also can be done if I deal with the sample project in HAP. So I believe you already receive this notes. I'm going to follow the same, and I believe you already received the software, and I request to please install. So let me proceed. So here I'm talking about this part 3 software. Part 3 consists of chapter 7.1 and chapter 8. 7.1 I'm considering HAP. Chapter 8 I'm considering as this machine selection. So first of all, the introduction part for this HAP you can find on screen. You see it's a computer tool, nothing but the software, which assists engineer, nothing but the mechanical engineer or the engineer who is dealing with the load calculation in designing the system for commercial building. Generally, this software is for the commercial projects, but it does not mean that you cannot use for residential project. You can use even for residential project also. In Gulf, even for a small villa project, they're using HAP software for the load calculation. So the HAP is offering two tools. Tool 1 is for the load calculation. You see, tool is a tool for estimating load and designing system. Designing system means we are not dealing with the machine selection, we are dealing with the selecting the system. Okay, initially based on the building survey you're going to select the system, no? The same system we can select in HAP. For example, initially if you decided to go for split system or VRF system or chill water system, etc., that we are going to select in the software. Based on that, you'll get the options. For example, if you select chill water system, the option will be different compared with the slightly different compared with the DX system. So basically, this is for load calculation, not for machine selection. Machine selection can be done after getting the report from the HAB with the help of the vendor, means the manufacturer. So first is a tool for estimating load and designing system. At this level, just focus on tool 1 is for load calculation. Okay, and the tool 2 is for simulating energy use and calculating energy cost. This is optional. In all the project, you will not find this simulation. Generally, for big project, you will find this simulation part. But don't worry, in the school project, we'll deal with the energy simulation also, so that you can get the approximate idea about the total running cost of the project. And that will help to take the decision, especially for the big project, because you see, initial cost is one time, but running cost till the lifetime of the system. So this tool will help to simulate or to analyze what will be the annual running cost, nothing but energy cost, to take the decision by the client, so that whether he can able to afford that running cost as per the type of project, etc. So tool 1 is for load calculation, tool 2 is for simulating energy and calculating the energy cost. Okay, and both the tools you'll find in one software, but initially we'll deactivate that energy option. We'll deal with the load calculation, how I'll show you in today's session only. And the reports can be used to compare the building with the different system and can take the decision, especially for big project. The same project we can deal in load calculation using HAV with the different systems to compare the reports, especially for this energy cost. Okay, tonnage point of view, with the different system you'll not find much difference. Okay, but for energy point of view, you'll may find the difference. For example, if you compare DX system with the chill water system, you'll find the difference in energy, because chill water system is efficient compared with the DX system. So like this, we can use this software for analysis also, for especially for the energy point of view. Next. So ventilation standards, I think you remember we already discussed in part 2 in manual calculation. So here once again, user defined, nothing but the consultant may have their own standards. Again, the standard may be the ASHRAE or the SIPSI or the carrier, etc., what they adopt. So in actual practice, if the consultant have their own standards, you must follow the same. Next, carrier standard already discussed in part 2 in manual calculation, right? You're already aware of this. Next, we have ASHRAE standard 62.1, which we'll use in this in a school project. Okay, in the sample project, again I'll go for the with the with the carrier standard, so that we can compare with the manual. But in school project, we'll use this 62.1. Okay, so as a standard 60.1, I think you remember we discussed the standard and we did an example also to find the CFM for the sample project, and we got 29 CFM compared with the carrier. In carrier, we got 100 CFM in the sample project, and you know the difference between this carrier and ASHRAE 62.1. 62.1 uses what summation of both the values, na, people and area. Yes, online.
Yes, sir.
But carrier will use which is higher between the two. So 62.1 is basically for the commercial project. Similarly, we have 62.2. This is for residential. So the concept is same, but separate standard given for residential project. So as standard 62.2 is for residential. I have given the theory in the next pages also related to the 62.1 as well as 62.2. Next, you have a SIPSI. And you know who is SIPSI? Standard Institute of Building Services Engineers. Nothing but the society belongs to UK. Okay, so SIPSI have their own standards. So if you're working in UK, you're supposed to follow this SIPSI guides for the ventilation. Okay, similarly, if you're working in Australia or New Zealand, you're supposed to follow IRA. Likewise, you'll find the different standards. So the international standard mostly accepted in many locations is ASHRAE standard 62.1 or 62.2 based on the type of project. Apart from that, in actual practice, you must follow the standard which is approved by your consultant. We already aware of this because we discussed this in the previous manual in part 2. Next, 62.1, what I explained, the same you can go through once, but the important point is here what I explained in the previous in manual also. You see, when values are specified for both outdoor requirement, they will be additive, right? Means we'll use a summation of both the values. That is that one point you must take care. And rest of the thing, like how to extract from the table, like table 6.1, you know. Similarly, 62.2, this is for what you see, residential building. 62.1 is for, here you can find out, you see, this is for commercial and institution buildings, but 62.2 is for, you see, residential building. That is the difference. Rest of the thing, the concept is same. Next, we have one more standard, ASTED and standard 90.1. You see, 90.1, as engineer should have the awareness of this. This is for energy standard for the building, except low-rise residential building. Energy standard refers to, for example, the U value of the wall cannot be cannot be more than say zero point 0.3. The U value for say for roof cannot be more than say 0.001. Like this, you'll find the codes under this ASHRAE standard 90.1. This is related to the energy side. And if you're dealing with a green building also, you must follow this standards which is offered by the ASHRAE standard 90.1. So this is basically, you see, energy standard for the building except low rise residential buildings. This also you may find in interview, and if you're dealing with the green building, you must follow this standards. I'll share you the PDF for this also. You can go through once. Just remember at this level, ASHRAE 90.1 is for what? Energy standard for building except low-rise residential buildings. So first, as I said, we'll deal with the sample project in HAP so that you'll get the overall idea of the software, as well as we can compare the result with the manual. Okay, and in sample project, I'm considering split system so that you'll get the chance to deal with one more system in HAP. So sample project with the split system, school project package with VAV, then school project package, school project chill water with CAV. Okay, so I can I'll show you one example, the school project with the VRF system also. Okay, so I'm trying to cover the multiple system with the same school project, but the sample project I'm going to use the split system. Okay, so that I can able to cover the multiple system for learning point of view. Because you see, for any project, if you talk about the library, weather, or the spaces, you'll find all this in HAP is going to be same, except system can be different. In one project I cannot show you all the system. That is also one reason I'm dealing with the sample project, so that I can cover one split system. Next, so let me start the HAP software with the school project. So first of all, very basic, what is what on screen? So you know how to install the software, and I believe you already received the link to download, so please install. And after completing the installation, you can access from the start button. So already create a shortcut at the taskbar, you can find out here the icon, or else click on the start and you can find here after completing the installation in the start button. You can just type HAP, you'll get this our analysis program 5.1. So we are dealing with the 5.1 version. In the previous batches I use 4.9 version, but from this batch I'm going to use this 5.1 version. So I'm going to select this. You can find here in the start button, or else you can make a shortcut at the taskbar, you can find at the bottom. Okay, so just click on this after completing the installation and click OK. You see, for this batch we have not done any project, right? So I'm going to cancel this. If you want to open the existing project what you already did, you can select, but for this batch we have not done any project, so I'm going to cancel this. And when you cancel, you see HAP assume that you are dealing with a new project and the preferences window will automatically open. But at this level I'm going to cancel this. But first let me show you what is what on screen. So first of all, what is what on screen? Here on the top of the screen, this we can call as title bar. So when you save the name of the project, you'll find the name of the project here. At this level, it's showing untitled because we have not saved the name of the project. So this is called title bar. And below this project edit, view, report, these are all menus. Like any other software, like in AutoCAD or in the software, you'll find the menus. Now, similarly, you'll find the menus. For example, you see, when I click on this project menu, you'll get the options: edit, view, report, etc. These are all menus, or say drop down menus. Below this, you'll find some standard icons, like you see, new, save, sorry, open, save. Similarly, you'll find archive, retrieve, etc. Some tools which you can find under this project or this under this menus also, but here is a shortcut. Okay, for example, you see this creating a new project or opening a project or save, all this you'll find here in the project menu. Okay, or this archive or retrieve. So here's a shortcut for the same tools which you can find under the drop down menus also. How to use we'll discuss, don't worry, at this level just the introduction part. Next, left side of the screen, this area up to this line, say point 1 to 2, this we can call as a tree view. And after this right side, say point 2 to point 3, this is called list view. You can verify here. You see, after saving the name of the project, you'll find the name of the project here. Under the project, you'll find weather, space, system, plant, etc. So this is like a main, and these are the branches. So this is like a tree view. And on the right side you can find this space, system, etc. list. And when you select the space, you'll find the list of the spaces. When you select the system, you'll find the list of the system. And you can double click the space or system so that you can get a pop-up window, and that can be used to edit. Okay, so at this level just focus on terms and terminology. This is called list view, and the right side is called the list view. And at the bottom, this is called status toolbar. You can find the is ready or not here on the left side. On the right side, you'll find the standards. I'll set this one, and along with the date and time. So this is called status toolbar. So tree view, list view, status toolbar. On the top, you'll find the title bar with the menus and with the standard icons. Okay, so this is just an overview of screen. So how to use this we'll discuss. We'll deal with the steps. So step 1 is settings, basic settings for the project. In step 2 we'll discuss the sequence of operation. So here I'm dealing with the step 1 first. Step 1 is common for any project. You need to set the ventilation standards, the units of measurement, the energy standard, etc. Okay, so how to get that view for this step 1? Simple. You'll find this all step notes in the school project. At this level, just remember for the sample project. It's very simple. You can remember this one. So you see, for step one, I'm considering the project settings. And to access the project settings, simply you see you can go for project and click new. You will get the window. You see you'll get this preferences window, or else if you cancel this, what you can do, click on this view. Under this view drop down, you can find this preferences. You'll get the same window, preferences. So under preference, in the preference window, you'll find two tabs. One is a general tab, second is a project tab. And you see here in the project tab, I'm getting only ventilation standards, but you'll find some more options like energy standard, currency, etc. So how to activate that options? What you do, simply click on this general tab and enable energy feature. If you activate this energy feature, then only you can find the additional options. And as we discussed at the beginning of this session, HAP is offering two tools. One is for load calculation, second is for energy analysis. So if you want to activate the energy option, you must select this energy. So I'm selecting this, I'm activating this initially, and after selecting this, just to for learning point of view, I activate this. But in the sample project, I'm not dealing with the energy analysis. We'll deal with energy analysis in the school project. At this level, just for learning point of view, I activate this one, but we don't want at this level, so I'm going to deactivate this. Or else you see just the overview. For this, you'll find the additional option like lead rating, energy standard, currency, etc. Currency is required for energy analysis. Energy standard again for energy analysis. Lead rating, this is for the green building. You'll find the different standards for lead. Okay, so don't worry, we'll discuss this at the time of school project. At this level, I'm going to hide this by deselecting this energy option. So make sure that in actual practice also, initially we'll deactivate this option to avoid confusion. Because after completing the load calculation only, one can think for the energy option. Okay, so after completing the load calculation, we'll activate this to activate the additional option which is related to the energy analysis. So, and we can update that to get the annual energy consumption and annual running cost of the project. So at this level, I'm just deactivating this by unchecking this energy analysis enable energy option. So you must deselect this initially. Again, click on this project. I'm selecting the ventilation standard. So in this project, I'm using this ventilation standard 62.1, and as per this 5.1 version is available up to 2016. But anyhow, this 62.1 is important. 62.1 we already discussed at the beginning. This is the ventilation standard for commercial and the institution buildings. So HAP is basically for the commercial project. But if you want to use say 62.1 or user defined energy standard or carrier standard, that option is also available. How, I'll show you at the time of preparing spaces. But initially I'm selecting this as a standard 62.1, and in the general tab, make sure that select the proper units. So here I'm dealing with what? So the sample project we did with which system, English or metric? Is online. You see, we use degree Fahrenheit, CFM, tonnage, etc. That all belongs to what?
English.
English. Okay, so that's the reason I'm selecting English system here. But don't worry, after completing all the input, if you change this to SI metric, automatically the software will convert all the input to metric. So for you as a beginner, you can take the advantage of this. Initially, use any one system. Later, after saving the project, you can change the system. Automatically, the software will do the conversion so that you can get some idea. So at this level, I'm selecting English system, and here's the option to enter the email address of a sales engineer, so that after completing a project, you can send a copy to a sales engineer for at the initial stage for preparing the quotation. So at this level, it's not a technical point, so I'm ignoring this. Next, here you see show tooltip. When you select this show tooltip, at the bottom left, you'll find the information. I'll show you how. At this level, I'm selecting this. So show tooltip means when you take the cursor to the particular option, you'll get the information at the bottom left. So if you want to get the some basic information at the bottom left, make sure that select this option. I'll show you how. At this level, make sure that's selected. Next, show date and time on the right side. And if I remove this on the right side, you'll not find the date and time. Right, I want this, so I'm selecting this, and make sure that energy option is not selected as we discussed. Okay, and click OK, and simply save the project. And I'm going to provide the name, say sample project. By default, you can see the location. It will save on the C drive. E22 is a default folder. When you install the software, it will create, and the name of the project is sample project. This is a location. Okay, if you want, you can change the location also, but here at this level, I'm using a default location. So click save. You see step one, which is general setting, is done. Next step two. Step two, I'm considering the sequence of operation, how to follow the sequence in HAP. So remember, the first step is here on screen. You see, the first step is input weather data. This is step one. And the step two is the library. You need to update the library. How I'll show you, don't worry. Just at this level, try to understand the sequence of operation. Step one is and all this step after completing the project settings, what we did just now. So after completing the project setting, step one is input weather data as per your location. Step two is updating project library, like updating the U value for the wall, roof, window, door, etc., including the schedules if applicable. I'll show you this. Next, step three is creating spaces. And after the space or spaces, in this project, sample project, only one space. Next, step four is creating a system. After completing the system, you can generate the report. If it is chill water system, then step 5 also will include. Step 5 is for plant, is applicable only for chill water system, not for DX system. And say for DX system, after system, step 5 is detecting reports, generating the reports. In the report, you'll get the tonnage, CFM, entering dry bulb temperature, leaving dry bulb temperature, entering wet bulb, leaving wet bulb, coil ADP, all these parameters you'll get in the report that can be used to select the system. So these are the steps and you must follow the sequence. You see, step 1 and 2, if you want, you can shuffle. First, you can complete the library, then weather, or first library, first weather, then library. There is no issue. But after completing the weather and library only, one can deal with the space. Because in the space, we are going to link this information, what we are going to create in the library. So this sequence is important. And after completing the spaces only, one can create the system, because in the system we can link the spaces. So without spaces, we cannot, there is no question of creating the system. So except step 1 and 2, all the other steps you must follow in sequence. Are you getting this online?
Yes, sir.
So let me proceed with the step 1, which is weather. So in weather, we learn how to provide the input as per your location. So there are two options. You can update the weather information from the HAP library, or if the option is not available or the city is not available, we can update that weather manually. So let me share the screen. So simply what you can do, you can select weather from where? From tree view, and double click in the list view to get the pop-up window, and so that we can update. Okay, so again in this weather property also you'll find the multiple types like design parameter, design temperature, solar design, or simulation, etc. Simulation is not active because the energy option is not activated na? So this is not activated. So user input is only design parameter. If you provide this design parameter, automatically the software will generate design temperature, design solar. Design temperature is for getting the maximum temperature for conduction heat gain, and design solar, nothing but solar heat gain. Like for example, we use table number 15 for solar heat gain at the time of dealing with the glass, or else similarly we have this equivalent temperature for the wall, etc. So all belongs to solar, no? So this automatically the software will generate if you provide this design parameter input. So this tab 1 is a user input, remaining automatically generated by the software. So in the tab 1 design parameter also, if you know the location, and if the location is available in the HAP library, simply you can select. For example, this sample project is belongs to which location? Hyderabad, no? So Hyderabad comes under India comes under Asia Pacific. So I'm selecting this Asia Pacific, then location I'm selecting India, and here you'll find the list of city. You see, if your city is available in the list, you can select. If not, we can create. For example, consider location, say Bangalore. If the Bangalore is your project, select the Bangalore. Automatically the software will catch the latitude, longitude, elevation, dry bulb, wet bulb, etc. But one problem with the software, still you see this, we are dealing with 5.1 version, but still this version uses, you can notice here at the bottom, 2001 ASHA handbook, the source, but this is outdated. So in actual practice, we'll provide this input based on the latest handbook or the updated data. Even though the city is available, for example, Bangalore is your city for project, for example, will not use this because the source is outdated, and we have the updated data now. that is 2021 handbook. So we can provide the user input from their hand. Anyhow, the Hyderabad city is not available in the list, so you must provide this. So what you can do, you can select the nearest city. If the city is not available even in Ashtray, one can select the nearest city. What we use last say 7 years or 10 years back, all the city data was not available, so we use the nearest city available for rough calculations. Anyhow, 100% accurate load calculation is difficult, so we use the nearest city. But now the data is available for almost all the city. Okay, so what you can do, we can create. So how to create? Simple. You can just delete and type your own, say Hyderabad, and enter the latitude. So latitude, I think remember, we already create the input now for the sample project. So latitude was 17 point. Yes, 17.45. Good. Here 17.45. But where is the option to enter north or south? I think remember we discussed this in part 2, chapter 6. We are considering positive values for north and negative values for south now. If you enter positive value, the software will consider this as north. If you enter minus something, the software will consider as south. So here you not get the option to select north and south, because for latitude means north and south now, longitude is east and west. So positive values for cities, or else simply what you can do, you can use the quick reference. Okay, or quick help. Simply what you do, click on this tab, and you see when I select on this latitude, at the bottom you can find maximum 90, minimum minus 90, and this is called tooltip information, what we select at the beginning in the settings, tooltip information. Similarly, when I select here for the longitude, you'll get a minus 180 plus 180 to minus 180. You know these options, you know this range. So left side is a tooltip information. If you activate in the settings, you'll get this. And if you enter, for example, you see maximum is 90, minimum is minus 90. For example, if I enter 100, the software will not accept. It will show you in the red. And when you try to save also, it will not save. So anyhow, it's a very useful option. So this range will help you. But if you enter the wrong value in the range, the software will accept. So don't think that always will software will help you. If you enter the value out of the range, the software will indicate this. But wrong value within the range, the software will accept. So be careful. So anyhow, latitude is what, 17.45. And if you want to get the quick help or quick reference, what you do, select on this particular or any tab and press F1. You see the site latitude is used for solar radiation calculation. And what we discuss, positive values for use for the city north of the equator, negative values are used for south of the equator, what we discussed at the time of chapter 6, the same. But for quick reference, you can press F1, just select on this latitude, you'll get the latitude information. For example, if you want to get the longitude information, click on the longitude and press F1. You see, for longitude, I think remember we discussed this, positive values for west and negative values for
East.
east. You see, positive values are used for the west and the negative values is for east, the same. So here we are dealing with Hyderabad city. So the longitude was
46.
78.47 east, right? So east
46.
is so east is what, negative na? So minus 78.46.
46.
So minus indicate what?
East.
East. Next elevation
Elevation
17.
42.
Right, what we got from Asher Handbook, Asher Meteor website, right? Nothing but Asher Handbook version 21. Next, summer dry bulb 10.
106.
Good, 106. You can find all this here. I have given the input again in this chapter also. You see, dry bulb, wet bulb, latitude, longitude, everything is given. The same I'm going to use. So 106 degree Fahrenheit, and summer coincident wet bulb. What we adopt is 70.
79 point.
9. And why we adopt the 79, the peak condition, because
Yes.
we deal with the manual na? But you see, along with the dry bulb, you'll get the wet bulb also when you select the city. That case again we discussed in the school project. At this level, I'm considering the peak 79.5. Next, daily range 20.9.
Yes, sir.
But you can notice here, you see, when I enter 17.45, the software round off to 17.5, because here you'll find 1 digit accuracy. Okay. Next, winter dry bulb. Winter dry bulb we use for the heating calculation, right?
Yes, sir.
So what was that? 58 something. Can you please find out from the notes? chapter 7. Okay, I'm considering this. It is a will confirm. I need to install the software. Next, you'll find some new parameters here on screen. You see app atmospheric clearance number. This is a new parameter we have not discussed in manual. Na? So you'll find some additional parameter which is not done in manual. So let me explain this. You see atmospheric clearance number is for solar sky radiation. Means the quality of the solar sky radiation. For example, consider a building and say here's the sun and the radiation from the sun on this building. So you'll find the different atmospheric condition. Na? One atmospheric condition is clear condition. In case of clear condition, we can consider the radiation is completely fall on the building. In that case, we can consider this number as 1. Nothing but in calculation, the software will consider the solar load as 100%. One case is clear condition. Second case is a very clear. In very clear condition, like in Gulf or very some hot regions, we'll consider 1.15. This one is for typical, nothing but clear condition. We have one more value, 1.15. This is for very clear. Very clear, we are considering additional 15%. So 15% additional heat gain through radiation we are considering for reflection from the other bodies. 100% from the sun and reflection from the other bodies around the building in case of very clear. And we have one more condition like hazy condition. Hazy condition, you see, in case of hill stations or in some location, even in summer, you'll find some cloudy condition. So the radiation cannot completely fall on the project, on the building, because of this hazy mean nothing but because of clouds. In that case, this value we are considering as 0.85. Nothing but we in the software will consider 85% for radiation calculation. The software will not consider or will consider only 85%, means 15% is losses. I'll show you exactly. The same you can find in the theory also when you press F1. What I explain. You see, typical range 1.15 for very clear condition. 1 is for typical condition, nothing but standard condition. 0.85 for very hazy condition. In most commonly in actual practice, we are considering 1. If you are very sure that, in that case, we can go for 1.15 or 0.85. But in actual practice, we are considering 1. Means in the calculation, we'll consider radiation calculation as 100%, means 1. So in this project also, I'm considering 1. Anyhow, in Hyderabad, in summer, you'll find the clear conditions. So we'll go for 1 only. Next, we have average ground reflectance. You see, in most of the cases, this atmospheric clearance number, average ground reflectance on soil conductivity, we are taking as the default values. Generally, will not change this unless and until if you have the specific or more precise values. But at this level, we are learning, so don't get confused. All the time, we are not supposed to enter all the values. Some default values will follow the same, but at this level, we are learning, so I'm explaining this. Okay, so don't panic. It's simple. So here you see next option is the average ground reflectance. This is the value based on the reflectivity of radiation around the building, and this depend on the type of material. For example, around the building, if it is a white color tiles, so what will happen, the reflection is going to more na? Compare with the bitumen roads, means dark color roads. If the dark color roads around the building, there is no garden, then the reflection is less because black body absorb more radiation, reflection is less. If it is a white color floors, the reflection is more. Or if it is a grass or garden around the building, the reflection considered as a medium. So this is for average ground reflectance. When you press F1, you'll find the value based on the material. Again, you see here, if it is a new concrete, the value is 31.31 to 0.34, means 31 to 34% reflectivity. Similarly, old concrete 22 to 25%, but the default value used by the HAP is 0.2, the crushed rock. Okay, if it is a green grass up to 31%, etc., and the reference also given. And if you refer this 2021 ASHRAE handbook also, this values will not change because these are the standards. But mostly in actual practice, we'll follow the standard, that is 0.2. So if you know exactly, enter the value from the architect. or else use the default value. At this level, I'm using the default value. Next, we have one more new parameter, soil conductivity. This is for slab on grade or for -1 or -2 or negative loads. Okay, soil conductivity. Again, this depend on the type of soil. Na? For example, you see when I press F1, sand, slit, clay, loam. Based on that, you have these values. So as per the type of material, the conductivity values will change. So in school project, we'll use this value. At this level, I'm using the default value as 0.8. Next, we have this design calculation cooling months. So you see CLG is short of cooling. So design cooling calculation months. Here when you select January to December, the software will analyze for 12 months. And based on the 12-month analysis, the software will provide the peak information in the report. For example, if I select say January to say June, because in Hyderabad, the peak summer say from February up to this May or the mid of June. So I'm selecting this February to June. So in this case, the software will analyze only the month from February to June, and based on that, the peak information extract by the software and generate in the report. But this information just to save the time in calculation. For example, if I select January, December, in that case, the software analyzes for 12 months. So this option was useful in like 5 years or 7 years back when we use a low speed systems to save just the calculation time. But now we are dealing with the high configuration with minimum 8 GB RAM with i5 or i7 etc. So this option, even if you select January December for small project, you'll not feel that difference in the calculation time. It may increase some seconds, but it will generate that option report quickly. In case of multiple spaces like 100 spaces or multiple spaces with the different system, this option will help to save the time in the calculation. But at this level, I'm selecting January December so that the software will analyze for total 12 months for the cooling. Okay, but for example, if you want to deal with the cooling plus heating, then provide the cooling month. So the software will analyze the information for the cooling months. Remaining months, the software will use for the heating point of view. Okay, again to save the time. Or else if you select January, December, the software will check for 12 months for cooling as well as heating to generate the peak information. So at this level, I'm selecting January, December. Let the software decide the peak condition based on the block load. At this in this case, we have only simple one sample project, so block load concept is not applicable. But in case of multiple spaces, block load concept what we discuss in part 2 chapter 7. Block load concept means all the spaces at a time will not get the peak condition, right? So for that reason also this will be useful. Next, here time zone for India, you see when you select India, automatically you'll get this one. So actually it should be plus 5.5 because India as per GMT is a plus 5.5. And daylight saving, I'm selecting no. But what is daylight saving, I'll show you in the school project, because for India is not applicable. Yeah, but for school project which belongs to US or for UK or for Canada, Australia, this daylight saving option is applicable. I'll show you in the school project which belongs to US. Okay, at this level, what really I'm ignoring. When you enter all this information, automatically the software will generate this. When you click OK, again I'm going to open this. You see, here you'll find the design temperature and design solar. What is design temperature? You see, January to December, the peak in the month of, you see, July and August. Here 106. Similarly, for the peak on the right side, we'll find hourly details. For example, in the month of January, for the hottest day, this is a 24 hours profile for dry bulb and wet bulb. You can scroll down, you can find out for total 24 hours. You see 23 means completion of 23 means again 0. So for total 24 hours, you'll find January the dry bulb and wet bulb peak day condition. Similarly for February, you can scroll for total 12 months. This is for your information. The software will use this. Similarly, design solar, here you can find out January to December. But for what orientation, you can find north, northeast, east northeast, east, etc. For total 16 orientation, as we discussed in the manual. In software you'll find total 16 orientation. In between north and east you'll find northeast in manual, what we discussed, but here in between north and northeast you'll find north northeast at the rate of 22.5 degrees. Total 8 orientation plus horizontal at the rate of 45 degrees, but here total 16 orientation at the rate of 22.5. So all this orientation solar information you can find out plus horizontal. This can be used for skylight or for roof calculation. And this is a solar heat gain. And I think remember we use this kind of information from table 15, like 163 BTU per hour, 23 BTU per hour for north, for 163 BTU per hour for south for solar heat gain. So you can verify here BTU per hour per square feet. This is a design day max solar heat gain. The software will use this. This is not the user input. When you enter this design parameter, automatically the software will generate. Okay, as per the orientation, as per the type of what we are going to add in the space. Okay, getting this information online.
Yes, sir.
This hashtag calamity data to get this to update this winter coincident red bulb. So you see I'm selecting heating and location in Hyderabad. Dry bulb here, wet bulb. I'm selecting this wet bulb and you see 48.47, so I'm rounding off to 49. Okay, this is one way to get this winter coincident red bulb. So now the weather is update for this Hyderabad sample project. Click OK and save the file. So you see under this step 2 was a sequence like weather, space, etc. Under step 3 I did this weather. Okay, so what you do, just practice this weather and just go through this. First install the software, so complete the installation and open the software, go through once what is on screen and complete this weather before next session. Hope you got the idea about the weather. So in the next session, we'll continue the library. And if you want the complete video course, please find the description below this video and you can click on that link so that it will take you to our website, and from our website you can directly purchase HAP video course, which consists of a sample and the school project with 8+ hours. Thank you.